Germany, Mecklenburg at the Rechlin-Lärz Airfield in March 1944. The Technical Intelligence Service of the Luftwaffe had established the systematic examination of captured enemy aircraft as a vital function. At Airprobungsstelle Rechlin, the Reich's main center for aircraft evaluation and testing, teams of pilots and engineers diligently worked to grasp every aerial advantage the Allies held in the war. What was uncovered by them in the early spring of 1944 would dramatically reshape their view of American industrial capacity and the overall direction of the air war above Germany. The arrival of the Mustang on March 6, 1944, the captured P-51 Mustang reached Rechlin. It had been transported by rail from its crash site near Brandenburg. Just 2 days earlier, the aircraft had been downed during the first American fighter escort mission to Berlin. The pilot did not survive the impact, but the airframe stayed largely intact, giving German technical personnel their most complete specimen yet of the plane that was quickly shifting the balance of air power over the Reich. Hermann Göring's nephew, Hermann von Bombach, who was involved in aircraft development and would later command Kampfgeschwader 200, supervised its initial inspection. Inside the cockpit were the young American pilot's navigation charts, which outlined the route from an airfield at Debden in England to Berlin and back, a round trip of over 2,000 miles. The technical evaluation began without delay. German intelligence had been monitoring reports of increased deep American fighter activity over German territory, but their official assessment was still that single-engine fighters lacked the sufficient range to escort bombers all the way to Berlin. The distance from bases in England to the German capital was approximately 560 miles one way. Even with external fuel tanks, standard fighter aircraft couldn't carry enough fuel for such a long mission while retaining full combat capability. This judgment was rooted in the analysis of earlier captured aircraft. The P-38 Lightnings and P-47 Thunderbolts, both of which had shown limited penetration into German airspace before fuel restrictions necessitated their return. Shattered assumptions. These assumptions were shattered by the events of March 4th and 6th, 1944. On March 4th, P-51 Mustangs from the 4th Fighter Group flew their first mission in the new aircraft, having converted from P-47s just days prior. They escorted a small bomber contingent to Berlin. Although communication and weather issues hampered the mission's effectiveness, with only 32 bombers reaching the target, the significance was undeniable. American single-engine fighters had reached Berlin, fought in combat, and made it back to England. 2 days later, on March the 6th, roughly 660 bombers attacked Berlin in daylight. They were escorted by over 150 P-51 Mustangs, alongside P-47 Thunderbolt and P-38 Lightning groups. The escort fighters engaged Luftwaffe interceptors above the German capital and remained with the bombers on their way home. This was clearly not a one-off fluke. The Americans had definitively solved the escort fighter problem. General der Jagdflieger, General Major Adolf Galland, one of Germany's most successful fighter aces with over 100 victories, flew combat missions during this period despite his administrative role. He encountered the P-51 formations over Germany and instantly understood the consequences. His combat assessments, submitted through official channels, observed that the American fighters were operating at full combat capability over Berlin, attacking aggressively with no signs of fuel conservation. They were not flying at the limits of their range. They had reserves. This completely contradicted everything Luftwaffe intelligence believed regarding American fighter capabilities. Galland's reports also stressed the P-51's superior performance at high altitude, where its speed and maneuverability outclassed both the Fokker-Wulf FW-190 and the Messerschmitt Bf-109 above 20,000 feet, the range secret the eye. Technical examination at Rechlin initially concentrated on finding out how the Americans had achieved this range. The evaluation team measured the P-51B's internal fuel capacity. The aircraft was equipped with 2 wing tanks, each holding 92 gallons of aviation fuel, for a total of 184 gallons in the wings. An additional 85-gallon fuel tank was located within the fuselage, directly behind the cockpit. This fuselage tank was a relatively recent feature, added to the P-51B design during production to boost range. The total internal fuel capacity was 269 gallons. The Packard-built Merlin engine, a licensed version of the Rolls-Royce Merlin, which had revolutionized the Mustang's high-altitude performance, consumed fuel at rates that varied with the power settings. At economy cruise, the engine burned approximately 60 gallons per hour. Fuel consumption rose to about 75 gallons per hour at normal cruise power. German engineers calculated the range using these figures. With 269 gallons of internal fuel and a cruise consumption of approximately 70 gallons per hour, the P-51B could fly for about 3.8 hours. At a cruising speed of roughly 300 meticulously, this translated to a maximum range of 1,140 miles. This was just barely enough to complete the round trip to Berlin from English bases, and it left no reserves for combat operations. However, combat reports unequivocally showed that American fighters had engaged in extended dogfights over Berlin, sometimes lasting 15 to 20 minutes before flying home. Combat power settings consumed fuel at rates exceeding 100 gallons per hour. Such high fuel use should have made it impossible for the aircraft to complete the return journey. The calculations could not account for the observations of German pilots in combat. The answer: paper drop tanks. The solution became clear when the technical staff examined the aircraft's wing structure more closely. The P-51B had standardized hardpoints beneath each wing for external stores. These attachment points included fuel line connections, indicating a specific design for external fuel tanks. Drop tanks weren't a new idea. Since the Battle of Britain, German fighters had been using them. The FW-190 regularly employed them for extended-range missions, and the Bf-109 could carry a 300-liter drop tank. All air forces considered it standard practice. Drop tanks provided extra external fuel and were then jettisoned before combat to minimize drag and weight. The question wasn't if the Americans used them, but what capacity these tanks had and how the Americans were producing them in the required volume to maintain their operational. Tempo intelligence officers immediately started a search for American drop tanks from the March missions. They mapped probable jettison points based on the engagement locations reported by Luftwaffe pilots. Drop tanks were typically released upon encountering enemy fighters, as external stores diminish speed and maneuverability. Search teams consisting of Wehrmacht personnel and Hitler Youth volunteers scoured the forests and countryside northeast of Berlin for debris from the air battles. Industrial disparity within 3 days. Several objects were retrieved from the region's fields and forests. Most were fragmented, damaged by the fall or crushed on impact. But 2 examples arrived at Rechlin in relatively intact condition, having been cushioned by landing in soft soil or winter wheat. These captured drop tanks instantly changed the German understanding of American industrial methods. The tanks were cylindrical, measuring about 108 inches in length, with a diameter of roughly 22 inches at the widest point. Capacity estimates showed that each tank held roughly 108 US gallons, 400 liters. 2 such tanks would supply an extra 216 gallons of fuel, boosting the P-51's total fuel capacity to 485 gallons. With this fuel load, the Mustang could fly for approximately 6.7 hours at cruise settings, giving it a range exceeding 2,000 miles. This was more than enough for the Berlin mission, including substantial combat reserves. The fuel capacity mathematics now finally made sense. However, it wasn't the capacity of the tanks that immediately seized the German engineers' attention, but their construction. The drop tanks were not made of metal. Touching the surface revealed a texture unlike steel or aluminum. Even the silver paint couldn't mask the underlying material. When engineers carefully scraped away a small patch of paint, they found multiple layers of heavy paper, each about 0.5 millimeter thick, laminated and compressed using a resinous adhesive. The construction was clearly sophisticated and deliberate. The tail and nose cones were shaped from overlapping pieces of paper material pressed like papier-mâché, creating a visible scalloped texture where the pieces overlapped. The center section was a seamless wrap of continuous layers around a cylindrical form. The fuel fittings were precisely machined brass and properly sealed. Peering through the filler cap showed an interior coated with a cellulose-based lacquer intended to resist the corrosive effects of aviation gasoline. The material analysis German material specialists were brought in for a detailed analysis of the tank's construction. The paper was identified as kraft paper, produced using a chemical pulping process that creates exceptionally strong cellulose fibers. the same material used for industrial packaging and heavy-duty shipping containers. The adhesive was a resorcinol formaldehyde resin, a thermosetting polymer that formed bonds stronger than the paper itself once heat-cured. The lamination involved at least 12 separate paper layers, each carefully oriented for multi-directional strength. Wooden anti-slosh baffles were installed inside to prevent fuel from surging during maneuvers. The entire construction process was clearly designed for mass production and standardization. Crucially, the empty tank weighed about 80 pounds, compared to 65 to 75 pounds for a metal tank of smaller capacity. The paper construction was not significantly lighter than metal, but it offered a different set of advantages. The implications were instantly apparent to the technical staff at Rechlin. The Americans were making fuel tanks from non-strategic materials. Wood-based resins and paper didn't require the steel, aluminum, or other metals that were becoming increasingly scarce in wartime economies. The manufacturing process needed no skilled metalworkers, no specialized metalwork equipment, and no forming or welding of sheet metal. These tanks could be produced in any packaging factory or paper mill with relatively simple modifications to existing equipment. The United States possessed hundreds of such facilities. If even a small fraction of American paper production was shifted to drop tank manufacturing, output could reach thousands of units per week. The tanks had no manufacturer markings, no serial numbers, nothing to suggest limited production. They were commodity items, completely expendable and mass-produced. The scale of American industry intelligence officers began investigating American paper industry capacity. Before the war, the United States produced about 12 million tons of paper annually, with production increasing during wartime mobilization. Converting even 1% of this capacity to drop tank production would yield over 100,000 tanks per month, far exceeding any plausible requirement for P-51 operations. The actual constraint would not be materials, but the availability of labor and manufacturing equipment for assembly. However, this type of manufacturing was exactly what semi-skilled workers could perform after minimal training. The paper tanks demonstrated resource optimization and industrial efficiency on a scale German planners struggled to grasp. Additional analysis revealed more details about the paper tank's use and design. They were strictly single-use items. The resorcinol adhesive, while creating strong bonds when cured, was slowly dissolved by prolonged contact with aviation gasoline. Interrogation of captured American aircrew and intelligence reports suggested that paper tanks had to be filled immediately before flight and couldn't be stored filled for more than a few hours without developing leaks. This was not an operational limitation, as fighters were fueled just before a mission. The tanks would be used for a few hours, then jettisoned. Their single-use nature simplified logistics. No need for maintenance, inspection, or recovery for reuse. They were expendable by design, psychological impact, and operational assessment. The color coding was also noted. Paper drop tanks were painted silver, while metal tanks used by American forces were painted gray. This distinction allowed ground crews to quickly identify the tank type during fueling. The silver finish on paper tanks also helped to reflect solar heat, minimizing vapor pressure issues and fuel evaporation at altitude. Systematic engineering optimization for field use and mass production was evident in every aspect of the design. By late March 1944, German intelligence traced the origin of the paper drop tanks to British development. The Air Ministry in London had commissioned the development of impregnated paper fuel tanks in 1943 to conserve strategic metals, especially aluminum. The Bowater-Scott Corporation, using its paper manufacturing expertise, developed the production process. The tanks were quickly adopted by American forces, with multiple manufacturers in the United States and Britain producing them for USAAF fighter groups. British resource scarcity was the driver of the innovation, but it was being exploited on a massive scale by American industrial capacity. The broader implications went far beyond fuel tanks. German technical staff launched a systematic review of captured American equipment, searching for other examples of mass production techniques and industrial innovation. A consistent picture emerged. American equipment was not always technologically superior to German equivalents in terms of individual component performance. German optics were often better, German armor metallurgy was in some respects more advanced, and German small arms were often more sophisticated in design. However, American equipment was consistently more reliable, more standardized, better manufactured, and available in vastly greater quantities. The American method prioritized producibility over perfection. Components were designed for mass production from the start, utilizing standardized tooling and semi-skilled workers. Parts were interchangeable without hand-fitting. Assembly line methods increased output and reduced production time. The contrast with German production methods was stark. German equipment and weapons were often technical masterpieces, hand-fitted by skilled craftsmen. A German aircraft engine or tank represented the peak of precision engineering. But building such equipment demanded specialized tools, skilled labor, and significant time per unit. Production rates were constrained by the availability of master craftsmen and precision manufacturing equipment. The Germans constructed superior individual items. The Americans constructed adequate items in overwhelming quantity. In industrial warfare, quantity had proven decisive. The unwinnable war analysis of P-51 Mustang production demonstrated this principle. North American aviation designed the prototype in response to a British requirement in 1940. The prototype, NA-73X, was completed just 117 days after the contract was signed, one of the fastest design-to-prototype cycles in aviation history. By 1944, P-51 variants were being produced by North American at 2 facilities. The Englewood plant in California averaged roughly 364 Mustangs per month during peak production. Combined output across both facilities reached an average of approximately 574 P-51s per month during 1944, with production still accelerating. The scale and efficiency of this production system were unmatched by Germany. Combined, Focke-Wulf and Messerschmitt produced only about 600 fighters per month in early 1944. Despite using emergency priority programs and forced labor, German aircraft production could not match American output. The resource implications were equally grim. American aluminum production in 1944 reached about 1.25 million tons, a massive jump from pre-war production. In contrast, Germany's aluminum production peaked at approximately 250,000 tons per year and was declining due to the loss of bauxite sources and the bombing of production facilities. The Americans had about 10 times Germany's aluminum production capacity. The choice to make drop tanks from paper rather than aluminum was not driven by metal scarcity. The United States had enough aluminum to produce every drop tank in metal if they wished. Paper was chosen because it was cheaper, required less critical manufacturing equipment, freed up aluminum for other uses, and could be produced more quickly with less skilled labor. This was optimization, not desperation. The psychological impact of these findings rippled through the Luftwaffe's operational and technical communities. The paper drop tank became a symbol of American industrial capability and the massive fundamental disparity in resources between the combatants. Captured examples were displayed at technical briefings for Luftwaffe personnel. The message was unmistakable. American fighters could now escort bombers anywhere in Germany. The old defensive strategy of waiting for Allied fighters to turn back at their fuel limits was now obsolete. Luftwaffe fighters would have to engage the escorts to reach the bombers, and those engagements would cost aircraft and pilots at rates Germany could not sustain. Catastrophic losses. Galland presented the operational assessment in conferences with senior Luftwaffe leadership throughout the spring of 1944. He repeatedly emphasized that the P-51 was superior to German fighters above 20,000 feet, being faster than the Bf-109 and more maneuverable than the FW-190 at altitude. Its extended range, thanks to the drop tanks, allowed it to escort bombers throughout their mission profile. German fighters could no longer attack bomber formations unopposed after Allied escorts turned back. Every intercept now required fighting through the fighter screen. Loss rates were steadily climbing. In January 1944, the Luftwaffe lost about 90 fighters. By February, German losses had increased to roughly 160 aircraft. The trend was clear and unsustainable. The British and Americans could replace losses faster than Germany could inflict them. The full force of American escort fighter capability arrived in the summer of 1944. The 8th Air Force flew deep penetration raids almost daily, weather permitting. Mustangs provided continuous escort from England to targets across Germany and back. Luftwaffe fighter losses became catastrophic. In June 1944, approximately 350 day fighters were lost defending the Reich. July saw similar losses with a 31.2% monthly attrition rate. At these loss rates, experienced pilots were being killed faster than they could be replaced. Replacement pilots arriving from training schools had minimal flight time, perhaps 150 hours, compared to 300 hours or more for American pilots. Many German replacement pilots had as little as 30 hours in type before being assigned to operational squadrons. The combination of numerical inferiority, the experience gap, and the constant presence of P-51 escorts made daylight operations over Germany increasingly deadly for the Luftwaffe. The bitter irony Galland's repeated assessments to Hitler and senior Wehrmacht leadership throughout this period culminated in his September 1944 report, which stated bluntly, the Luftwaffe could not win the air war. Germany lacked the trained pilots, the aircraft, the fuel, and the resources to contest Allied air superiority. The American industrial capacity was beyond Germany's ability to counter through combat operations. The only feasible strategy was to husband remaining resources for the defense of critical targets and hope for a political settlement. Before complete collapse, the paper drop tanks continued to fall across Germany throughout late 1944 and into 1945. German civilians came to recognize the cylindrical shapes in the forests and fields. Initial reports sometimes mistook them for unexploded bombs, causing local panic until military authorities confirmed they were harmless fuel tanks. Civil defense organizations distributed instructions explaining that the silver cylinders falling from Allied aircraft were empty fuel tanks, not weapons. The psychological impact was noted in civilian morale reports. The sight of enemy aircraft overhead in such numbers, casually discarding expendable fuel tanks, reinforced the message that the Allies had resources to waste while Germany desperately scraped for every kilogram of aluminum and every liter of fuel. Documenting the disparity, technical intelligence continued to analyze captured American equipment throughout 1944, shifting its focus from understanding capabilities to documenting the industrial disparity's sheer scale. Could Germany manufacture similar paper drop tanks? Technically, yes. German paper mills could produce kraft paper, and the chemical industry could supply suitable resins. The process wasn't overly sophisticated. However, the practical answer was no. Germany's chemical industry was at maximum capacity, producing synthetic rubber, explosives, and other critical materials. Resin production for non-essential items could not be prioritized. The paper industry was fully committed to military requirements for packaging, maps, and documents. Most critically, there was no operational requirement for extended-range drop tanks. By late 1944, fuel shortages were grounding much of the Luftwaffe. Pilot training was reduced to minimal levels. Operational sorties were limited by fuel availability rather than aircraft availability. Building drop tanks to extend range was pointless when there was barely enough fuel for local defensive operations. The irony was stark and bitter for German planners. The Americans had solved the fighter range problem with paper fuel tanks, precisely when German fighters were grounded by fuel shortages. Different industrial bases, different problems, different outcomes. The Americans had more of everything: more aluminum, more industrial capacity, more fuel, more pilots, and sufficient excess capacity to optimize solutions like paper drop tanks. Germany was fighting a war of scarcity against an enemy for whom scarcity was not a constraint. The historical record by January 1945, the war's outcome was undeniable. The Luftwaffe could mount only sporadic resistance, limited by pilot losses and fuel availability. The systematic study of American equipment at Rechlin continued, but it had become an academic exercise. The findings were documented for the historical record, but they could no longer affect the war's outcome. The final, comprehensive analysis of the P-51 and its drop tanks was finished in late January 1945. The report detailed every technical aspect of the Mustang's range capability, the drop tank construction materials and methods, production estimates, and operational implications. The conclusion was unambiguous. The P-51 Mustang, equipped with expendable paper drop tanks manufactured from non-strategic materials, has rendered the German heartland indefensible against American daylight bombing. The report was filed in the Reich Air Ministry archives. Whether senior leadership ever read it is unknown. By then, technical reports analyzing American capabilities were merely confirming the reality already demonstrated on the battlefield. The Luftwaffe, which had dominated European skies in 1940, was reduced to occasional desperate sorties by early 1945, hoarding precious fuel for missions that could not change the strategic situation. American fighters established complete air supremacy, roaming freely over Germany, escorting bombers, and attacking targets of opportunity. Every paper drop tank falling from an American aircraft was a stark reminder of the industrial disparity that had decided the air war legacy. The paper drop tanks themselves became collector's items after the war. The few examples that survived became historical curiosities and museum artifacts. Their expendable nature meant they held little intrinsic value, and most were either crushed upon impact or deliberately destroyed by Allied ground crews. The National Air and Space Museum in Washington holds several examples in its collection, displayed next to the P-51 Mustang aircraft they were designed to serve. The information placards note their construction from laminated kraft paper impregnated with phenolic resin, their manufacture by companies like Bowater Scott, and their 108 US gallon capacity. The placards don't usually mention the weeks German engineers spent analyzing these tanks, calculating their implications, and ultimately realizing the profound strategic defeat they represented. Through these captured materials, they finally grasped the sheer magnitude of Allied industrial superiority. The historical record, preserved in post-war interviews and technical reports, reveals the deep psychological impact on German technical personnel. They were not examining a superior weapon. In fact, the paper drop tank was not an advanced technology. It was a deliberately simple design utilizing non-critical materials. Yet, this very simplicity delivered a message more devastating than any technical sophistication could have conveyed. The Allies possessed such overwhelming industrial capacity that they could afford to optimize designs for mass production over pure performance. They could manufacture fuel tanks from paper because they had unlimited manufacturing capacity, unlimited resin, unlimited paper, and unlimited fuel to fill the tanks. Efficiency, not scarcity, drove this optimization. Germany's experienced engineers understood the immediate meaning of this. They weren't fighting an enemy improvising with substitute materials out of desperation. They were fighting an enemy so rich in resources that substitution was a choice made for efficiency, not a constraint imposed by shortage. Post-war interrogations of Luftwaffe personnel consistently returned to this theme. When asked when they first knew Germany would lose the war, many senior officers and technical staff pinpointed the early spring of 1944 as the decisive turning point. The strategic balance shifted decisively with the arrival of long-range fighter escorts over Berlin. Post-war, Hermann Göring acknowledged that long-range fighters had inflicted a major strategic blow to German defensive planning and were among the most decisive factors in the air war's final outcome. While the exact quote about Mustangs over Berlin remains unverified in primary sources, Göring's statements consistently admitted that Allied air superiority, enabled by long-range escort fighters, had been decisive in Germany's defeat. The technical insights gained by German engineers at Rechlin, who scrutinized the captured drop tanks and P-51s, later influenced post-war aviation development. Many of these engineers worked with Allied technical intelligence services or immigrated to the United States. Their detailed knowledge of American design philosophy and production methods informed their later careers. The emphasis on standardization, design for manufacturability, and interchangeability of parts became standard practice in post-war aircraft development. The paper drop tank itself became a case study in wartime industrial innovation, taught in military staff colleges and engineering schools as an example of how mass production and resource optimization could provide a strategic advantage. A legacy of efficiency, the P-51 Mustang continued in service with various air forces for decades after World War II. It saw extensive combat in the Korean War, performing primarily in close air support and ground attack roles. The aircraft's excellent endurance and range, which made it a formidable escort fighter in Europe, proved equally valuable in Korea's different operating environment. P-51s remained in frontline service with some air forces until the early 1980s, a testament to the fundamental soundness of the design. Over 15,000 Mustangs were produced during and immediately after the war, making it one of the most numerous American fighters of that era. Today, more than 100 P-51s remain airworthy, maintained by museums and collectors globally. The sight of a Mustang in flight, often bearing the distinctive markings of its wartime units, is a reminder of the aircraft's crucial role in achieving Allied air supremacy over Europe. The broader historical significance of the paper drop tanks and the P-51 extends beyond their operational and tactical impact. They are a case study in industrial warfare and the critical importance of production capacity in modern conflict. World War II was ultimately decided in factories, not primarily on the battlefield. The side that could produce more ammunition, more aircraft, more weapons, more vehicles, and more supplies faster than they were consumed in combat held the decisive advantage. The United States achieved industrial mobilization on an unprecedented scale in history. At its peak production period in 1943-1944, American factories were producing ships at rates of multiple vessels per day and aircraft at rates exceeding 50,000 per year. This industrial output not only sustained American forces but also supplied vast amounts of equipment to the Soviet Union, Britain, and other Allied nations through Lend-Lease. Germany, despite its significant technical expertise and industrial capacity, could not match Allied production. The reasons were numerous: a smaller industrial base, the loss of access to raw materials as territory was captured, the strategic bombing of production facilities, the diversion of resources to competing priorities, and organizational inefficiencies. Most fundamentally, however, Germany was fighting a coalition whose combined industrial capacity was several times larger than its own. Once American industrial might fully mobilized and joined the Allied cause in 1942 to 1943, Axis defeat became inevitable. The paper drop tanks, falling across Germany from 1944 to 1945, served as a stark and simple symbol of this industrial reality, conveying a message that could not be misunderstood: the ultimate lesson. Systematic and professional examination of captured American equipment by German technical intelligence continued throughout the war at facilities like Rechlin. Their detailed records of technical assessments, material analysis, and performance testing provide valuable historical insight into how each side viewed the other's capabilities. German assessments of American equipment were generally technically accurate, correctly identifying the strengths and weaknesses of American weapons, vehicles, and aircraft. Where German analysis fundamentally failed was not in understanding individual items, but in comprehending the scale of American production and the implications of that scale for the war's outcome. A single P-51 Mustang was a very good fighter. 10,000 P-51 Mustangs represented air superiority that no technical innovation or tactical skill could overcome. The story of German engineers analyzing paper drop tanks at Rechlin in March 1944 is ultimately a story about the nature of industrial warfare. It shows that in conflicts between industrialized nations, production capacity becomes as important as battlefield prowess. The side that can build more efficiently, and faster, holds advantages that operational and tactical excellence cannot fully compensate for. This costly lesson, learned by Germany and Japan in World War II, continues to shape strategic thinking and influenced military planning throughout the Cold War. The ability to sustain the production of advanced weapons systems, maintain supply chains under duress, and outproduce an opponent over extended periods remains as critical today as it was in 1944. The March 1944 missions to Berlin, the first to be escorted all the way by single-engine fighters, marked the decisive turning point in the European air war. From that moment on, no target in Germany was safe from American bombers with fighter escort. The systematic bombing campaign proceeded with sustainable losses, relentlessly pressuring German war production. Synthetic fuel plants, ball-bearing factories, transportation networks, and aircraft production facilities all became targets that could be repeatedly attacked with fighter escort for the entire mission. The cumulative effect of this campaign, combined with Allied advances from the West and Soviet advances from the East, led to Germany's defeat 14 months after the first P-51s reached Berlin. The paper drop tanks served throughout this final period of the war, with thousands produced monthly for use by P-38 Lightnings, P-47 Thunderbolts, and P-51 Mustangs, as well as British fighters. This optimization of resources, prioritizing efficiency over tradition and matching production methods to requirements, exemplified the industrial approach that characterized successful Allied operations. The enduring legacy of the paper drop tank reminds us that effective solutions do not always need to be technically sophisticated. A tank made of glued paper, manufactured from non-critical materials and designed for single use, was the appropriate solution to the specific problem of extending fighter range. It was adequate for the mission. This principle, designing solutions that are adequate for purpose rather than pursuing technical perfection, became a fundamental concept in modern systems engineering. The best solution is the one that meets requirements and is manufacturable in the necessary quantities, within the time available, using accessible resources. The aircraft that carried those tanks, the P-51 Mustang, stands as one of aviation history's most successful fighter designs. Its combination of performance, range, producibility, and reliability made it the ideal escort fighter for the strategic bombing campaign. The Mustang's success was not due to a single factor, but to the successful integration of all its components: the powerful Merlin engine, the aerodynamically efficient airframe, the fuselage fuel tank, and the availability of drop tanks, all supported by the industrial capacity to produce them in massive quantity. This integration made the P-51 the decisive escort fighter of the European air war. 80 years after the events of March 1944, the lessons remain instructive. The paper drop tanks revealed not just technical details to the German engineers at Rechlin, but strategic realities. They demonstrated that the United States possessed industrial capacity beyond Germany's reach, that American engineering prioritized practical solutions over perfectionism, and that the Allies had enough resources to optimize for efficiency instead of making desperate substitutions. These revelations, arriving in March 1944 when the war's outcome was becoming increasingly clear, provided German technical staff with an unambiguous understanding of the challenges they faced. Though that understanding could not change the inevitable defeat, the story of those engineers, calculating fuel capacities and recognizing the implications of simple cylinders of glued kraft paper, offers a profound insight into how industrial capacity ultimately determines the outcome of modern conflicts.